Day 39, Honors Physics, Newton's 3 Laws, Example 32. Here we have two separate objects. I have the free body diagrams drawn for each of these. There is a shortcut method to this problem. Some of you might be able to figure out the shortcut. I'm not going to do this by the shortcut right now. I'm going to show you the general technique for solving these problems, because if there's friction involved, it's really hard to take any shortcuts. Because there's no friction in this one, there's a shortcut you could take. But I don't want you to get used to taking shortcuts, because when you have friction, the problem becomes compounded fairly greatly. But anyways, we're applying F net equals ma to each of the two masses. It says to calculate the acceleration of each mass and the tension in the core. Well, they're each going to have the same acceleration. One's down and one's to the right, but the same magnitude. And the other principle here is that we're assuming a massless rope and a frictionless pulley. It says light cord. So we're taking a lot of simplifications that later on we may factor in that will make the problem much more difficult. But for now, F net equals ma on each of these two masses. So if you do the one that's on the table, F net equals ma. Well, there's only one force acting on that, and that's T. So it'll be T equals 4A. Two unknowns. Over here on the right, F net equals ma. I'm writing this down every time, but you really don't need to say F net equals ma. You can do that if you want. I actually prefer you to do that, but I don't take points off if you don't. But what I do want are diagrams every time. So make sure you draw these diagrams, these accurate free body force diagrams, at least with all the proper arrows. You don't have to have the exact correct length, but try to make them roughly proportional to their size. Anyway, F net here is big force minus small force. Well, the 40 is going to be bigger than T because the whole system will accelerate down, or at least that mass will accelerate down. So F net will be 40 minus T equals 4A. Once again, two unknowns, but we have a system of two equations with two unknowns, and we'll use simple substitution to solve this system. In other words, if I take this 4A and plug it in there, I'll have 40 minus 4A equals 4A. I'll write it down. The 4A's don't cancel, because if I add 4A to both sides, I get 40 equals 8A. A equals 5 meters per second squared. So the shortcut, well, I'll mention the shortcut would have been, you have two masses that are equal. This always turns out that the acceleration will be half of what gravity's acceleration is, or whatever planet you're on. But once you start throwing in, if they're equal masses, if they're two different size masses, the acceleration is not half of the normal acceleration. And once you throw friction in there, it really compounds the problem. So beware of that. We're applying F net equals ma.